There are thousands of different types of matter in the world, some with remarkable properties and many different characteristics. The natural environment contains many different types of matter, including that found in plants and that found in different types of animals. Objects made by humans also contain thousands of different types of matter. With all this different matter in the world, how do we go about classifying it? During the next few minutes, we are going to explore some of the ways matter is categorized and described. We are also going to explore mixtures and solutions. Let's look at water, a substance that all living things need to survive. Water comes in different phases, depending on temperature. Here, water at 0 degrees centigrade is as solid as seen in the icicles that are beginning to melt. And water above 100 degrees centigrade exists in the gas phase or steam seen here coming out of this beaker. Water exists in 3 phases. If we were to classify it based on its phase, we would incorrectly call it 3 different things, even though it is still water. Next, let's look at these objects. What do they have in common? Well, they are all solids, but even though these substances are all solids, they are quite different from each other. So as you can see, classifying matter by its phase is not a very useful method if we want to specifically know of what a substance is made. To make the task of classifying an easier one, scientists developed a classification system based on the makeup or composition of matter. The first class of matter we're going to study is mixtures. This rock, called granite, can be tooled to form many things such as building stones. Granite is formed deep within the earth and is excavated in large mines such as this one. It is not a pure substance, but is made of many different minerals that keep their individual identity. It is made of minerals such as pink feldspar, mica, and quartz. It is a mixture. A mixture is matter that is made of 2 or more substances mixed together but not chemically combined. There are hundreds of different mixtures, including this sand on the beach, made of different kinds of sand, rocks, and shells. This soil being tilled with this machine is also a mixture. A closer look shows it is made of different particles of dirt, stones, and plant roots. These tomatoes, carrots, and mushrooms are being cut up to be part of a mixture. The mixture is this salad being created. Mixtures are classified by how well mixed they are. As you can see, this salad does not appear to be the same throughout. Heterogeneous mixtures are substances in which the components are not evenly distributed. Vinegar and oil, seen here in 2 separate layers, is used as a salad dressing. It is a poorly mixed, heterogeneous mixture, and that is why it needs to be shaken before pouring. This cereal is another heterogeneous mixture. It is made up of oats, seeds, coconut, and raisins. Each component, when added to the mixture, retains its individual properties and is not chemically combined. Homogeneous mixtures, like this paint, are different from heterogeneous mixtures in that they are well mixed and the same throughout. This milk is a homogeneous mixture in that it is chemically the same throughout. Other examples of homogeneous mixtures include toothpaste. Perfume is also a homogeneous mixture. Having explored the differences between homogeneous and heterogeneous mixtures, let's consider the 3 types of mixtures: colloids, suspensions, and solutions. Mixtures, like paint, are called colloids. A colloid is a mixture in which the particles are mixed together but not dissolved. The particles in colloids do not settle out and are continually bombarding each other. Shaving cream is a foam that is a colloid. Fog and smoke are colloids and appear quite cloudy. The liquid on the left is a gelatin, a colloid. The liquid on the right is colored water, a non-colloid. Due to the properties of the gelatin, light can pass through it, and the particles seen, but the particles in the colored water on the right cannot be seen. A suspension is a heterogeneous mixture in which some of the particles settle out. The particles and the water in this paperweight form a suspension. The water in this raging river also forms a suspension. This flask of water was taken from the silty river. Let's see what happens if we let it stand for several hours. After a few hours, you can see the water is clear and the particles have settled to the bottom. If you look closely, you can see different sizes of particles. When rivers rise over their banks, as seen here, silt and particles often drop out of suspension. "70% of the earth is covered with a very well-mixed liquid, seawater. Seawater is a solution. A solution is a very well-mixed mixture in which particles are small and most often dissolved. In seawater, many different chemicals, including salt, are dissolved in water, giving seawater a homogeneous or very well-mixed appearance. Another common solution consists of the gases nitrogen, oxygen, and other gases. It is the air we breathe. Let's make up a solution that is great to drink, lemonade. A solution has something that is dissolved and something that the substance is dissolved in. We will begin squeezing some lemons to make lemon juice. The juice from the lemon is called the solute. A solute is a substance that is dissolved in another substance. Now let's add the juice to some water. Water is the solvent. A solvent is a substance in which the solute is dissolved. To sweeten the lemonade, we will add another solute, sugar. Many things dissolve in water, and it is often called the universal solvent. In our lemonade, notice that it is the same color and taste throughout the liquid. This is a property of solutions. Most soda drinks are injected with carbon dioxide, a harmless gas that you can hear when opening a soda can. The gas gives the drink its fizz. Many soda drinks have gases such as carbon dioxide that are dissolved in the liquid. When a substance, like these flavored drink crystals, dissolve into another substance, like water, it is said to be soluble. When a substance is soluble, it can dissolve into a solvent. When one substance, like oil, cannot dissolve into another substance, like water, it is said to be insoluble. When a substance is insoluble, it cannot dissolve into a specific solvent. When adding chocolate syrup to your milk, you usually stir it for a while. Why? Because stirring speeds up the rate of dissolving. In other words, it helps more solute, the chocolate syrup, come in contact with more solvent, the milk. Rate of dissolving is also affected by particle size. These large particles and these small particles are both salt. When equal amounts are placed in water, you can see that the smaller particles dissolve quicker than the larger salt particles. This is because the smaller particles have more combined surface area and come in contact with more solvent. Temperature also has an effect on the rate of dissolving. As temperature increases, the rate of dissolving tends to increase. Here you can see the salt easily dissolves in hot water on the right, as compared to the same amount of salt in cold water dissolved on the left. After stirring for a couple of minutes, you can see that the salt in the hot water dissolved more than in the cold water, where there is salt left on the bottom of the beaker. Solubility is a measure of how much solute can be completely dissolved in a solvent. There is a limit to how much solute can dissolve in a solvent. In other words, a solvent, such as water, can only dissolve so much sugar before the sugar remains on the bottom of the beaker. Solubility is usually expressed in terms of grams of solute that can be dissolved in 100 milliliters of water at a specific temperature, usually 20 degrees centigrade. For example, the solubility of copper sulfate is about 32 grams per 100 milliliters of water at 20 degrees centigrade. If more copper sulfate is added at this temperature, it will not dissolve and remain as a solid. Here, the solution is said to be saturated. A saturated solution is a solution that has dissolved all the solute it can at a specific temperature. If the temperature is raised to over 90 degrees centigrade, then as much as 100 grams of copper sulfate can be dissolved. This graph shows the relationship between temperature and the solubility of copper sulfate, CuSO4. As the temperature of the solvent increases, the solubility increases. Any solution above the line in the graph is saturated, and any solution below the line is unsaturated. But the opposite is true with gases dissolved in water. As the temperature of the solvent increases, the solubility of the gas decreases. Warm bodies of water, such as this lake, hold less dissolved oxygen than cold ones. For their survival, these trout need to live in cold water that holds more dissolved oxygen. This graph shows the relationship between temperature in degrees centigrade on the left axis and the concentration of dissolved oxygen in the water on the bottom axis. As the temperature increases, the solubility of dissolved oxygen decreases. Solutions can exist as solids, not just as liquids and gases. Take, for example, this hot piece of steel. It is a solution. Steel is made up of a solution of iron, chromium, and other metals. It is an alloy. An alloy refers to metals in which two or more solids are dissolved together. These sterling silver eating utensils are an alloy made of silver and copper. In summary, a mixture is either well mixed, called a homogeneous mixture, or it is not well mixed, called a heterogeneous mixture. And there are three types of mixtures: colloids, in which the particles are visible and not completely dissolved; suspensions, in which the particles are of different sizes and settle out over time; and solutions, in which the particles are dissolved and are evenly mixed. You use mixtures and solutions every day. Try to notice them and classify them. You just might be surprised at the number of mixtures and solutions you use. Fill in the correct word when you hear this tone. Good luck, and let's get started. Number 1. A mixture is not well mixed. Number 2. A mixture is the same throughout. Number 3. In a colloid, the particles are Number 4. Muddy river water is an example of a Number 5. In a solution, the particles are Number 6. The is the part of the solution that does the dissolving. Number 7. Is often called the universal solvent. Number 8. The is the part of the solution that is dissolved. Number 9. Particles tend to dissolve faster than larger ones. Number 10. An is a metal made of two or more solids.